6G, I just did a bit of a change of 6G question, but I added all types of transformation. There is a reflection, dilation, translation in both horizontal and vertical. And a different restricted domain, not from 0 to 2 pi, but negative pi to pi. So here we go. The things that you must have: axis intercepts. You must have endpoints. You don't have to label the maximum minimums, but that just even that already, as I'm saying, endpoints and your axis intercepts are your two key marks. And then you get your shape. So let's get the shape first. So here we go. I start off by reading the transformation, but before I do in this first box, you should just identify what you can see. Amplitude. What is the amplitude? Can I please have, let's go with Ian. What's the amplitude for this equation here? 2. Very good. Some students will say negative 2. It is not. It is the actual absolute value. So it's not negative 2. It is 2. Very good. What is the period? Can I please have, let's go with Joe. Good. It's 2 pi on n, and n is this current value here. So n equals 2. So hence 2 pi on 2, which gives you pi. Very good. How I'm going to teach you how to sketch. I'm encouraging you to use a quarter period. You don't have to, but I think this helps. So find the quarter of the period. So currently it's pi. So pi divided by 4. That's your quarter period. Okay. Now, the next one may depend on how strong your exact values and symmetry properties are. You can look at it and tell me the answer. If you can't, then you can write it out. So here we go. Y-intercept, you let x equal to 0. Try to solve for y. So what I'm asking you to do is to solve for negative 2 times cos of, that's pretty much what, 0 plus pi and 3, so pi and 3, so 2 pi and 3 plus 1. That's what I'm pretty much asking you to do there when you sub-zero in. Let's see. Alex, are you here today? No, Alex is not here. Usually I ask him for the exact values and symmetry properties. Let's go with Ryan then. Ryan, what is cos of 2 pi and 3? It is? Negative half. Very good. This is the second quadrant. So for those, again, who aren't yet confident, 2 pi and 3 is short of pi by pi and 3. So you're in the second quadrant. Cos is negative in this region. And using your finger or exact values, we know that cos of pi on 3 is half. So hence this is negative half. Negative 2 times negative half plus 1. That gives you negative 2 times negative half is positive 1. Positive 1 plus 1, 2. So I know my y-intercept must be at 0, 2. Okay. Endpoints. Same thing again. We're going to use exact values and symmetry properties. Let's go with another person. So f of pi, so right at the very endpoint of pi, I'm essentially asking you to figure out what's negative 2 times cos of 2 bracket pi plus pi on 3. Okay, and then plus 1. For those who aren't strong, again, you can think of this as, if you expand it, that becomes 2 pi plus 2 pi on 3. Or if it makes it easier, if you combine the fractions, I'm essentially asking you to find cos of what? 3 times 2 is 6. 6 plus 2, 8 pi and 3. That's essentially what I'm asking you to figure out. Negative 2 times cos of 8 pi and 3 plus 1. That's essentially what we're asking here. So let's see. So you can either work through here, you can work through there, or you can work through here, whichever one you feel most comfortable with. How did I get 8 pi and 3? I just did 3 times 2. So 3 lots of 2, 6. 6 plus 2 is 8, so 8 pi and 3. What's cos of 8 pi on 3? Can I please have, I'll choose this side around. Let's go with this side. Let's go with Tara. What's cos of 8 pi on 3? It is negative half as well. If you can visualize it, this is closest to 9. It's like saying 9 pi on 3 minus pi on 3. 9 pi on 3 is the same thing as 3 pi. 3 pi is starting here and minusing, so you're quadrant 2. So it must be negative half again. And that means the answer is 2. It's still 2. Okay, so at pi, it's 2. What about negative pi? Same thing again. Negative 2 times cos of 2 times negative pi plus pi on 3. Again, it's up to you how you want to solve it. it might help if you condense it into one fraction, or you can look at it as 2 pi plus 2 pi and 3. You can predict where roughly it is. But again, I'm just going to write it out clearly for you to see. Here we go. Cos negative 2 pi plus 2 pi on 3. Or you can think of it as cos of negative 6 plus 2 is negative 4 pi on 3. Don't forget there's a plus 1 and times a negative 2. Here we go. What is cos of negative 4 pi on 3? Can I please have, let's go and do Pat? It is half is exact value, but it is not positive. It is negative just because that's in the negative region. So if we picture it, that's right. That's all right. Negative, that's the same thing as writing negative 3 pi on 3 minus an extra pi on 3. So if you visualize that, negative pi is over here, and if you minus further, you're in quadrant 2. So cos is negative, and then it's cos of pi on 3. That's okay. I'll put you on the spotlight there. So negative 2 times negative half plus 1. And again, you'll find that it ends up pretty much all the same. So it's 2, 2, 2, 2. All right, good. So those part there, exact values and symmetry properties, that's what I meant. You can't solve for endpoints. You can't sketch without knowing exact values and symmetry properties. Yeah? Next part. You cannot solve without knowing your symmetry properties and exact values for axis intercepts, even though technically this could be a bit easier than endpoints. Here we go. X-intercept occurs when y is equal to 0. So I'm asking you to solve 0 is equal to negative 2 cos of 2 bracket pi plus pi on 3, close brackets, plus 1. Okay, so for those who haven't done 6, I think it's 6D or 6E, one of the two. 6E probably. Here we go, let's do this. You do exactly what you've been doing, inverse operations. Get rid of the plus minuses. So here's a plus 1, minus 1 both sides. That cancels out. Next line, I get now negative 1 is equal to negative 2 times cos of 2 bracket pi plus pi on 3. Close brackets. Addition, subtraction's gone. So next one is multiplication, division. Here's the times negative 2. So divide both sides by negative 2. Negative 2 cancels out. And you get half is equal to cos of 2 times pi plus pi on 3. We're almost there. And then this next step is what exercise 6E is about. It's about you finding all the possible solutions. How do you get rid of cos again? What's the opposite of cos? Oh yeah, where'd the x go? Oh, sorry, that pi is the x. Thank you. X, X, X. Cos inverse, yes. So we know that to get rid of this cos, we do cos inverse. So what we're really doing is 2 bracket x plus pi on 3, that's what's left over, is equal to, what is the cos inverse of half? This is where you have to think about your unit circle. And the way I've taught it to you guys is just work between the 0 to 2 pi. Find the first two solutions and the rest follow the period. Okay, that to me is the easiest way to sort of do them. You can restrict the domain. It's up to you however you learn it. I don't care as long as you can solve it. So I like to go just from 0 to 2 pi, find the first two solutions. When is cos? Cos represents the x-axis. When is cos positive? Cos is positive over here, so that means it has to be these two quadrants. So that means for it to be half, x is half here. So that means you can either have a point up here or you can have a point down here. Now you go back to exact values. Cos of what gives you half? Let's go with Samuel. Cos of what will give you half? Pi on 3, very good. Again, you can use the hand method or the triangle method. I don't care. You just need to remember it. So we know this has to be 0 moves up by pi on 3, or 2 pi minus pi on 3 will get you those two possible solutions. So that's what I would write. I would say my answer is 2 bracket x plus pi on 3. Cos inverse of that could either be 0 plus pi on 3, or it could be 2 pi minus pi on 3. Okay, those are my two possible solutions. Once I've got my two, simplify it. Here we go. That gives me now pi on 3. And that's what, 5 pi on 3. This is 2 bracket x plus pi on 3. And your job is to find x. So get rid of the 2. Divide both sides by 2. Divide this by 2. Divide this by 2. And you now have, in your next line, x plus pi on 3 will equal to pi on 6, 5 pi on 6. Okay, because I'm dividing them all by 2. And your final step to get x, get rid of the pi on 3. So here we go, subtract pi on 3 on both sides. But since the denominator is out of 6, in my mind, I would convert the pi on 3 into denominators of 6, which is the same thing as saying 2 pi minus 2 pi on 6. That's the same thing as saying minus pi on 3. So if you minus 2 pi on 6 on both sides, that just tells you x could equal to 1 take away 2 is negative pi on 6. 5 take away 2 is 3 pi on 6. You got your first two solutions with all the dilations and reflections and translations all sorted there. Okay? Now, to find all the possible solutions, add minus the period. We know the period before Joe told us was pi. So pi up here is your period. Since it's out of 6, just do 6 pi out of 6. So that means you're just adding and subtracting by 6. So go down. Here we go. Let's add and subtract. Notice that these two are a difference of 4 units. Negative pi to 3 pi is 4 units. So you can use 1. Just keep adding 6. So negative 1 plus 6 is 5 pi on 6. Plus another 6 is 11 pi on 6. Plus another 6, that gives you 17 pi on 6. And I can keep going. But then to know what your gaps are, well, they're 4 units apart. So 5 plus 4 is 9. 11 plus 4 is 15. 17 plus 4 is 21. You just fill it in. See what I'm doing? I'm not actually following a unit circle anymore. I literally just do it by symmetry. So I know the next one must be then 9 pi on 6, 15 pi on 6, 21 pi on 6. But obviously, I'm showing off here, you don't need to go that far. The domain was only from negative pi to pi. So to get pi, I need it to be 6. So it gets cut off right here. All of these do not fit in the domain. Negative pi, well, I can still go backwards, so make sure to subtract by 6 as well. So if I subtract by 6, that gives you now negative 7 pi on 6. And then this one, if you subtract by 6, is negative 3 pi on 6. So which ones fit? This one doesn't fit. That's beyond negative pi. So it gets cut off here. So these are my two cutoffs. What are my solutions? You've got negative 3 pi on 6, which is really negative pi on 2. That's negative pi on 6. You got 3 pi on 6 again, which is pi on 2. And your last one is 5 pi on 6. These are your x-intercepts. So when you sketch this, I expect you to have 4 x-intercepts. See what I'm doing there? Okay, so again, this is 6E. If you haven't practiced that, that's going to be examinable. Usually if they test, they'll test something like that. So there we go. We've got our 4 axis intercepts. I don't care how you do it. Your tutors might teach you differently. This is what I found the easiest way. Just find the first 2, add and subtract the period. Right? All right, team. Now's the sketching. So what have I been teaching you in the last session to sketch? I found that if you use the quarter period and you use transformations to read where the first starting point is, it's easiest to sketch. Okay, so you told me amplitude is 2. But because there's a +1, that means your maximum number is 3 and your minimum number is -1. Yeah, because it's usually -2 to 2. Now it's 1 to 3. Yeah? So in my picture, I'm picturing your maximum value is at 3. Minimum value is -1 based on the amplitude. Okay? And because it's gone up by 1, your middle line must be here. That's what I'm saying. Okay? So find your starting point and then just keep adding on your quarter period so that you can get your shapes. So here we go. Where's my starting point? Let's read the transformation. We already knew up by 1, which we've accounted for. Does this move left or right? How do we know? Where's the graph go? Left or right? Left, right here. That's from your transformation. That tells me left by pi and 3. So I can say left pi and 3, okay? And the rest doesn't matter. So from here, starting point, going up by 1, which we already knew, going up by 1. But what type of graph do we have? We've got was it a cos? Yeah. Cosine. Remember, cosine goes top, mid, bottom. Top, mid, bottom, mid, top. That's what a cosine graph normally looks like. So if you follow the first point we said to the left by pi on 3. So your starting point should be at pi on 3. So it should be here. Right there. Left by pi on 3. Okay? Maximum is 3. So there we go. It's gone up by 1. It's gone to the left by pi on 3. So right there is my starting point. How do you find your next few points? Quarter cycle. You told me quarter cycle is pi on 4. You told me the starting point is negative pi on 3. So here we go. X was equal to negative pi on 3. That's your starting point. If you want to find the next point, add on the quarter cycle. But when you add on, you see how the denominators are different? Make it the same. And if you change your axes to that, whatever that denominator is, your graph will look beautiful. Right? So here, what's the lowest common multiple for 3 and 4? 12. So that means this is the same thing as writing negative 4 pi on 12 plus 3 pi on 12. So all I know is keep adding 3. If you change the scale to just pi on 12s, you'll be able to go through that. If you want it even more beautiful, you can match the axis intercepts with this one. So if you match them, denominator is 6, denominator is 12, and clearly they also have a common multiple of 12. So if you use 12s, it should fit very nicely. Right? So that's how you can make them really beautiful if you want to make the scale correct. Otherwise, I usually just stick with this scale. Right? So I usually make sure starting point and your quarter period, they have the same denominators. That's my new x-axis scale. Okay? So in your graph, I've already done that for you. This is mainly in pi and 12s. I just simplified it for you there. Okay, so that will be negative 2 pi and 12. In the middle is then 1 pi and 12. And it goes on. So you can see here, if you're moving only by 3, so remember you're moving from negative 4 pi on 12, which is the equivalent to negative pi on 3, you're adding on 3 pi on 12s every time. So here we go. Let's go look at our scale. So here's your negative 4 pi on 12, right? Negative pi on 6 is the same thing as saying negative 2 pi on 12. So the middle is 3. So this is where negative 3 is. This is where negative 1 is. And if you change the scale, I should have actually made it in terms of 12 rather than that one, actually. But now we know it's the middle. So now, if you count it, you need to move 3 back to get to the middle. So 3 back. 1, 2, 3. So negative 4 pi plus 3 pi on 12 will give you negative pi on 12. So right here, I know my next point is right there. Then you add another 3. So negative 1 plus 3 gives you 2, which is over here. That's 2 pi on 12. And then if you add another 3, so 2 plus 3 is 5. So that's... yeah, it doesn't help when the scales are simplified here for you. This is 4. So 5 is over here. There we go. That's 5. So 5 pi on 12 is over here. That's 6. So 7 must be here. 8 must be here. 9, 10. So if you follow on that scale, 5 plus 3 gives you 8. So next one is up here. And then 8 plus 3 is 11. So 11's over here. And then 11 plus another 3 gives you 14. But obviously, you don't get to the max. Sorry? Why is it a negative graph? Oh, I didn't see. Sorry, I did forget the negative. I forgot the negative. I didn't look at the reflection. It just means the other way around then. So you just flip it around. So that means instead of it being up there, it would have been down here. So we've got a circle down here instead. Still in the middle there. That means this one gets flipped over. So delete that. Comes back. And then this one comes to the bottom. Comes back up top. And if we go the other direction, -4 minus, so this is now -5, -6, -7, -8, -9, -10, -11, -12. So if we follow that again, -4 minus 3 gives you -7, so it's over here. -7 minus another 3, minus 10 up here. And then -10 minus 3. Wait, did I do something wrong? 4, 7, 10. Yeah, that's good. 13 is on this side. So that means it's coming down. There we go. And this one is coming up. So that means they must stop all at the same spot. What was the end point again? It was at 2, yeah? Yeah, so negative pi, this is your end point at 2. So negative pi 2. This was also at pi 2. So pi 2. And you can see, if I just put it all together, whoa, 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 whoa. There we go. I didn't actually check the x-axis intercepts correctly. I just followed the dots there. What was our x-axis intercepts again? It was at negative pi on 2. That's negative pi on 6, pi on 2, and 5 pi on 6. So, how did my graph go? Oh, not too bad. Yeah, that's negative pi on 2. Pi on 6, that was good. Pi on 2 again, and pi on 6. Oh, I hit it. I hit it all. It's beautiful. Yeah, but the axes help had I kept it all in 12s. If you kept it all in 12s, it would have been easier to see. So right there, that's your x-axis intercept. Right here, negative pi on 2, 0. Next one, negative pi on 6, 0. Next one, pi on 2, 0. And then finally, 5 pi on 2, 0. And my y-intercept was at 0, 2. And look at that, team. If we stuck to the 12s rather than the scale that I gave you, if you had 12s, it would have been easier. So you stick to the denominator of 12, and that's what I mean by it's easy to draw beautifully. But as I'm explaining that, that's 23 minutes with me explaining. So the first time when you do it, adding on with the calculations, it could take about 15 to 20 minutes, roughly, for the first time. You used to have to do that. You don't do it now. But you do have to know how to find the x-axis intercepts. Okay, so I gave you another one to have a go. But yeah, I find that if you found the starting point, find the quarter cycle, scale it, makes it much easier to then solve. Okay, so I'm going to stop the video there.